Hello everyone, you're welcome back to the channel. Today we are going to solve a very important physics problem on moment of a force. Now let's look at the question. A uniform rod AB, 2 meters long, weighs 0.40 Newton. If weight of 0.80 Newton and 0.40 Newton are suspended from A and B respectively, at what point will it balance? We are told that a uniform rod AB, which is 2 meters long, weighs 0.40 Newton. A weight of 0.80 Newton is suspended from end A, and another weight of 0.40 Newton is suspended from end B. The question now is, at what point will the rod balance? The first thing we must do in question like this is to draw a neat diagram. We are told the rod AB is 2 meters long, so draw a straight horizontal line and label the ends A and B. From the question, weight of 0.80 Newton is suspended from end A. At point A, draw a downward arrow and label it 0.80 Newton. From the question also, weight of 0.40 Newton is suspended from end B. At point B, draw another downward arrow and label it 0.40 Newton. Now, because the rod is uniform, its weight acts at the center of the rod. Since the rod is 2 meters long, the center is 1 meter from both A and B. So at the midpoint, draw a downward arrow and label it 0.40 Newton, which is the weight of the rod. Next, we assume that the rod balances at a point P. Let the distance of this point P from A be x meter. Now let's identify the distance from the point of balance. The distance from A to P is x. The distance from the midpoint to P is 1 minus x. And the distance from B to P is 2 minus x. At this point, we apply the principle of moment. The principle of moment states that for a body in equilibrium, the sum of the clockwise moment about a point is equal to the sum of the anticlockwise moment about the same point. Let's take moment about point P. The anticlockwise moment is produced by 0.80 Newton weight at A. So anticlockwise moment is 0.80 times x. The clockwise moments are produced by two forces. First, the weight of the rod, which is 0.40 Newton, acting at a distance of 1 minus x. Second, the 0.40 Newton weight at B, acting at a distance of 2 minus x. So the total clockwise moment is 0.40 times 1 minus x plus 0.40 times 2 minus x. Now we equate clockwise and anticlockwise moment. So we write 0.80x is equal to 0.40 in bracket 1 minus x bracket close plus 0.40 2 minus x in bracket. Expanding the bracket, 0.80x is equal to 0.40 minus 0.40x plus 0.8 minus 0.40x in bracket. Rearranging, 0.80x is equal to 0.40 plus 0.80 minus 0.40x minus 0.40x. Simplifying further, 0.80x is equal to 1.20 minus 0.80x. Bringing like terms together, 0.80x plus 0.80x is equal to 1.20. 1.60x is equal to 1.20. Finally, divide both sides by 1.60. X is equal to 0.75 meters. The rod will balance at a point 0.75 meters from A. Always remember, draw your diagram clearly, state the principle of moment, show all your workings, and write your final answer with the correct unit. Thank you for watching. See you in the next class. Bye.